Hey everyone, welcome back to another video. So today we are going to discuss another room on TryHackMe. The room name is File Inclusion Vulnerability. So this room introduces file inclusion vulnerabilities, including local file inclusion, remote file inclusion for RFI, and directory. So basically, let's start with the introduction. What exactly is file inclusion? So this room aims to equip with essential knowledge to exploit file inclusion vulnerabilities, and including local file inclusion, remote file inclusion and directory, traversal. Also, we will discuss the risk of these vulnerabilities if they are formed and the required remediation. So we have provide some practical examples for each vulnerability as well as hands-on challenges. So in some scenarios, web applications are written to request access to files on a given system, including some images, static text, and so on via parameter. Parameters are query parameter strings attached to the URL that could be used to retrieve data or perform actions based on user input. And parameters generally are separated with the parameters for GET request, where you can see here is this question mark and then file is equester user cv.pdf. And here, if you see that on this entire URL, HTTP is basically the protocol, and then the entire domain name comes over after the protocol, and then we specify what file do we want to get, and we want to, let's say, get.php, and with the question mark sign, the query string begins, and after the question mark, there is usually the parameter, and the parameter is given the value, which is user cv.pdf, and as a result, it would give the CV of user on web app.TryHackMe. So for example, parameters are used with Google searching, where GET request passes user input into the search engine. So a common example is of Google, where when you are submitting a query on a Google, then the user input passes into the search engine, and it's generally shown as this. If you are not familiar with the topic, you can view how the web works. You understand this concept, and it's kind of basic how these web applications work, and we are aiming for a lot advanced level. Let's discuss a scenario where a user requests to access files from a web server. First, the user sends an HTTP request to the web server that includes a file to display. For example, if a user wants to access and display CV within the web application, the request may look like this. So we discussed this. So it's basically this entire request which the user is accessing, and where the file is the parameter and user.cv is the required file to be accessed. Now, user cv.pdf, so user wants to access that CV of him or some other user, and web server is served at this path var www and app. Now it processes and then goes to get.php, and get.php basically here you can see the entire structure of what basically is how it would process. And it's quite possible when you are a web server being served at this path, then we might be able to change the path and get to access to this entire CVs folder. As you can see, it's trying to directly goes into the user CV, but if we could change the path from user cv.pdf to some folder which is CVs or app or some other sensitive files that are being hosted on the web server, then we might be able to get access to that files and this entire. A vulnerability is called local file inclusion, LFI. So why do file inclusion vulnerabilities happen? File inclusion vulnerabilities are commonly found exploited in various programming languages for web applications, such as PHP, that are poorly written and implemented. The main issue of these vulnerabilities is the input validation, in which the user inputs are not sanitized or validated, and the user controls them. When the user is not logged in, the user can pass any input to the function causing the vulnerability. So basically, the file inclusion vulnerabilities generally do happen due to user input being not sanitized or validated. And what is the risk of file inclusion? We all know it could lead to RCE, some credentials being exposed, some sensitive information being exposed, some sensitive files being exposed. And yeah, let's continue to the next section and let's deploy the VM. Apply the VM attached to follow and apply the techniques as well as to the challenges. In order to access the VM, please make sure you're connected to the active network, and let's know we have deployed our VM. And now part crossfall, also known as directory crossfall, a web security vulnerability that allows an attacker to read operating system resources, such as local files on the server running an application. The attacker exploits this vulnerability by manipulating and abusing the web application's URL to locate and access files or directories stored outside the application's root directory. So generally, what might be the structure over here of it's quite possible that the web server might be hosted on Linux, and we all know the default structure for the Linux to store its files. And let's say if the request is for cv.userchv, and if we could just try to get the ASCII password, which generally contains hashes and informations of users on that particular web server, and we might be able to get passwords, and might be possible we end up getting hash, and then we might try to get the original password from that hash, and we might be able to log in. And if it isn't possible, we might be able to even get some RCE with that as well. And now suppose there isn't input validation, and instead of accessing the PDF files at www app CB's location, the web application retrieves the files from other directories, in this case at cpassword. Each ... entry moves one directory until it reaches the root directory. Then it changes the directory to etc, and from there it basically, so this ... / ... basically we are in the file structure, and if we want to get access to etc password, we have to jump a lot on the directories, and each ... is basically jumping from one directory to another till it reached etc password. And we can clearly see it. We got different users, and their permissions, or etc password basically contains different users and the files they do have access, or the permissions they do have access, while the etc shadow generally contains the entire user's hash and their usernames being stored on the web server or the machine. Similarly, if the web application runs on Windows Server, the attacker needs to provide Windows path, for example, if the attacker wants to read the boot.ini file located in C winboot loot.ini, then the attacker can try the following dependencies on the target or S version. So basically that entire moving from one directory to another and then specifying the boot.ini is basically what the file would, where the file would be located, and so's the same comp. The concept applies to all Linux operating systems where we climb directories until it reaches the root directory, which is usually where we want to go. Now, /etc/issue might contains an message, and C boot.ini contains the boot options for computers with BIOS firmware, and then the access request for Apache web server are access via access log /root and dart sshidrsa, where we would get access to sshid RSA keys, and we might etc shadow contains user passwords on hashword, and etc shadow contains information about the system's user password, and etc password has registered users that have access to the system, and proc/version specifies the version of the Linux kernel, and etc/profile control system wide kernel variables such as export variables and facing mass. So what function causes part transfer radius in PHP? The part passerby ladies off occur when the user input is passed to a function such as file generate contents in PHP filecat contents, So this would be access to our course. This would be answer to our question, and yeah. Local file inclusion. LFI attacks against web applications are often due to developers' lack of security awareness in the PHP using functions such as include, require, include ones, and require ones often contribute to a vulnerable application. So here we are going to discuss why these vulnerabilities generally do exist. In this section, we will walk through various LFI scenarios and how to exploit them. The first scenario, suppose a web application provides two languages and the user can select between EN and AR. These are two languages that the application provides, and the PHP code above uses a GET request via the URL parameter. So let's say the parameters language is the slang for language. To include the files of the page, the call can be done by sending the following SGTP request as follows. So webapp.trackme index.php and language is equal to eng.php to load the English page, or on this ar.php and replacing en with ar.php generally switches the language from one language to another, and theoretically we can access and display any readable files on the server from the code above if there isn't any input validation. So let's say we want to read the etc password file, which contains sensitive information about the users of Linux operating system. We can cry getting etc password by just specifying with file parameter. And in this case, it works because there isn't a directory specified in the include function and no input validation. And there is no input validation, and we end up getting the etc password. Now apply what we have discussed and cry to read the etc password file. Also answer the question 1. So there is another scenario over there. In the following code, the developer decided to specify the directory loaded inside the function. And let's say the languages directory. In the above code, the developer decided to use the include function and call PHP pages in the languages directly only via lang parameters. If there is no input validation, the attacker can manipulate the URL by replacing the lang input with other operating system sensitive files such as etc password or even etc shadow. And again, the payload looks to be similar to Traversal. Sorry, I might be pronouncing it. It's wrong. It's called path traversal, but the include function allows us to include any code bytes into the current page. So we might end up getting sensitive, false. If a lab tried to read that C password, what would be the request URL be? So the request URL will be this. I guess. We are gonna cry on our own application. Okay, so find inclusion lab, and let's try on the lab one. Include a file in the input form below. So we are gonna solve the lab? I guess. Include a file in the input form below, so. Etsy password? Oh, we got access to the Etsy password. What would be the request URL? It could be this, and slash lab1.php, and then we specify to file parameter 2 0 is equal to, so, oh, sorry, there was UIL encoding over there. And now this would be the correct answer. And yeah, in the lab2, what is the directory specified in the include function? So we want to retrieve the directory. Let's say the So I am going to go for hint. Then this is the hint we are looking for, trying to enter an invalid input to check the error message. So, okay. Let's try to get an invalid input slash nen. Current path is basically this. File content include. There's no such file or directory anything function. File owning include path user routecat PHP /var /stable lab2.php, I guess. /lib PHP 5.2. So why not try accessing that entire path over here? So in the laptop, what is the directory specified in the include function? So you can see here clearly that it includes and yeah. Now, LFI, let's continue our topic soon. In this task, we will go a little bit deeper into qualify. So we discussed a couple of techniques to bypass the filter within the include function. Let's discuss our case in a free. So basically, in the first two cases, we checked the code for the web app, and then we knew how to exploit it. However, in this case, we are performing black box testing. So what is basically black box testing? So black box testing is a type of penetration testing in which you usually don't have access to the source code, and you generally have to figure out what would be the vulnerability on your own. And you would be provided with lists, weave sources, and yeah. So in this scenario, we have the following entry point: web app.trackme/index.php, and language is the parameter which has the value en. So if we enter an invalid input such as trigger, we get the following error: failed to open the stream, no such file or directory in this entire path on line 12. So the error message exposes information by entering TryHackMe as the input, and error shows what the include function looks like. So it is really essential to look for errors like we did in the lab number 2. Here we get to know about the directory, and it was includes, and often the errors usually do indicate a lot, or whether you are dealing on LFI or some other vulnerabilities in the web application. So if you look at the directory closely, we can tell the function includes files in the languages directory is adding a .php at the end of the entry. So thus the valid input will be something as follows: index.php with the parameter lang, which is equals to en, where en is located inside the given languages directory named en.php. Also, the error message disclosed another piece of information about the full web application directory path, which is this, and thus the part of the directory is also exposed, and we would generally try to directory traversal section in which we discussed to go back into the directories until we reach the root directory, and then we try to get the etc password, and that is basically how the 4 / which is used to go back to the directories till which we got 4 directories here, which you can see here, where /w/esteem/fraud4, and so in order to roll back 4 directories, it will add this 4 // and then we will get access to the root directory. From the root, we will specify the path as password, and as a result, when we will access this URL, we will probably get the LFI, and we would get access to the XUPass file. And it seems we first move out of the HP directory, but still, the include function reads the input with the .php, and this tells us that the developer specifies the file type. To insert function to bypass this scenario, we can use the nil byte, which is modular 00. So nil bit is basically in the form using nil bytes, an injection technique where a URL encoded representation such as modulus as 00. The percentage sign is repass modulars. It's often used in your encoding, as you might see over here. There are modulars which generally are used when you are encoding up the URL. So you could think of it as trying to trick the web app into disregarding whatever comes after the nil byte. So by adding the nil byte at the end of the payload, we tell the include function to ignore anything after the nil byte, which may look like this, which is equal, which you can see here include languages. We got back to the tycree and then the nil byte, which is equivalent to etc password, but it basically says to ignore everything after that, and it basically tells to it tells the include function to ignore anything after the nil byte, which just shows up the etc password as the resort. Note the module is and 00 trick is fixed and not working with PHP 5.3.4 and above. So this vulnerability generally do exist on the PSP versions 5.3.4 and below versions you can expire this vulnerability. So now jumping on to the case in 04. So in this section, the developer decided to filter keywords to avoid disclosing sensitive information. The tpassword file is being filtered. There are two possible methods to bypass this filter. First, pipe using the null byte model as 00 or the current break at the end of the filtered keyboard. The next byte will be similar to we discussed earlier on AXI password accessing via LFI. So we could also use the null byte instead of just ignoring everything else, and which tells thing do function to generally look for SE password only, and it ignore everything afterward. So to make it clear, if we try this concept in the file system using cd, we will get back to the directory. However, if we do cd single dot, then it stays in the current directory. Similarly, if we try etc password, it will do it. It results to @c, and that's because we move one into the root. Now, if we try etc password /dot, the result will be sc/password, since the dot refers to the current directory. So you would often see when you are using a CLI based, when you are using command line. So let me explain you. So this is the path, but I'm pretty on root. So let's try getting to AT folder. So now here you can see we are in the etc folder. So let's say if we want to get extra password, then we would have to at the single dark, then we will get back to the same directory. Let me show. In working directory, we are in the same directory, and if we add double dot, then we will get back to the previous directory. So what adding a null byte does is to stay on that current directory and ignore going back to the previous directory, and once we got SC password, just stay on that directory and show the XC password. And that's pretty much what you need to focus on for the now. And the case note 5. Next, in the following scenario, the developer starts to use input validation by filtering some keywords. Let's test out and check the error message. We get the following error. Failed to open stream, no such file or directory in this file. If you check the error message in the etc password section, we know that web application replaces the // with the empty string. There are a couple of techniques we can use to bypass this. Firstly, we can send the following payload. So here is basically a warning being displayed up. Include languages /xc/password section. We discussed earlier on that web application replaces the dot or slash with an empty string. And here, let me explain you with this. So what is doing here, there is a PSP filter. This works because the PSP filter only matches and replaces the subset, restring, dot or slash, and it finds and doesn't do anything else, leaving what is pictured below. So it is quite possible there might be a PSP filter, and the owner of that website may be cautious about the LFI vulnerability, and they might have used a PHP filter. So what we will do in this case, we will use this payload, which will generally tell to ignore that and use this Doorbur slash, and basically the same to go back to the directory, first directory, and then to first back was war slash www slash stmas. So first get back to the www folder and then go back to war and then basically get back to root. And after you get the root, then jump into etc password and basically just give us the entire contents of etc password. And here by that, we basically bypassed the PHP filter. And yeah, so the case number 6 is finally we will discuss the case where the developer forces to include a read function from a defined directory. For example, if the web application asks to supply input that has to include directories such as en.psp, then to exploit this, we need to include a directory in the payload like so. So we can include a directory here as a parameter, and we are basically specifying that value with and the LFI vulnerability, and this would also result in being displayed up as the LFI vulnerability and being exploited. And yeah, that's pretty much give a lab free a cry to read AXI password. What does the request look like? So let's try lab 3 now. Okay, so we did this faster earlier on. What would this one was basically to use STTB language. This one was the entire. Yeah, so here you can clearly see up that the LFI vulnerability we are going to use, and this one was basically dealing with the language parameter where that was being passed up. If you do remember up, then we will use that null byte function as well when passing on the file about ASCII password. And let's try give lab free to click ASCII password. Look, does the request look like so? Let's try to first read ASCII password on their own. And let's see, so now here you can see if we just pass this for inclusion and we tried to use this one below slash file. No, I messed up. I'm sorry. So basically, we're jumping from one directory to another and specifying up the null byte as well. So yeah, we got the contents of etc password as a result. If lab are free, I'll try to read the etc password. So if you remember earlier on, we discussed to jump from one directory to another, where there was 3 directories bar/w/stma, and there was the one that was we tried to specify. Reading the tract is /4, and that includes the summary of almost the 4 the drag for B would jump up. So $/4 and then exit password and then specifying the lively NN. So which function is causing the Traversal transfer? In Traversal, I'm sorry I'm reading this name incorrect, but I hope that you're getting the sense. So there was the error that we caught earlier on. If we could just try then that error, then you would get what is being responsible for failing to open the stream. If we could just review the source port over here. Its password includes so jumping onto lab node 4. Now, which function is causing directory traversal in lab node 4? So let's try to look what exactly can be passed on lab input 4. Let's try giving it a manual input for now, and let's try to see what output do we get. So file name cannot be empty. File get content, and I guess that would be the answer for this. Which function is causing the fi get contents is causing the director function, the directory traversal in lab number 4, and I will explain you why. So yeah, here you can see that file get contents failed to open the stream, no such file or directory, and if we try to, this function basically is responsible for the entire type 3 traversal. Because at the end of the day, yeah, so lab node 4 was very easy. As you can see that in the lab node 4, we just passed the random input, and we can clearly see that file get content function is directly responsible for directory traversal in lab node 4. So try out lab number 6 and check what is the directory that has to be in the input field. So we did want to know what payload should be used for lab number 6. First, let's try to open up the lab number 6 over here. Yeah, so here on the lab node 6, if we could just try to give simple input, let's try giving. So access denied allowed files at try and profile on folder only. So private line OS6, and what is the directory that has to be in the input field? So trial output profile would be in the input field. Try out lab node 6 and read at the OS release what is the OS version ID. So a classic NFI expectation here. So we would use Trident profile as we do have access for that folder, and we discussed on the lab number 6 at the end that we specified the parameter value and then use that for the LFI vulnerability. So what we are going to use, we are going to specify a file over there, and we do have access to track the profile we discussed earlier on for the language, and we do have access for the EN language, and then we specify up that entire. So yeah, here you can see clearly we use this, and if we could just get the ATC OS release from this, then we would get the version which is 12.04. And yeah. Now jumping on to remote file inclusion. So what exactly is remote file inclusion? It is a technique to include remote files into a web application like LFI. The RFI occurs when improperly sanitizing user input, allowing attacker to inject an external URL into include function. One requirement for LFI is that the allow URL fopen option needs to be on. The risk of RFI is higher than LFI since RFI vulnerability allows an attacker to gain remote code execution on the server, so we did it. I did discuss with you earlier on that the LFI could eventually lead to remote code execution as well, and which LFI type that leads to remote code execution is called remote file inclusion, which is RFI. One requirement for RFI, which is allow URL fopen to be on, and other consequences of a successful RFI can be access, denial of service attack, a sensitive information disclosure as well. So an external server must communicate with the web application for a successful RFI attack where the attacker hosts malicious files on the server. Then the malicious file is injected into include function via HTTP request, and the content of malicious file executes on the vulnerable application server. So let's try to understand with this diagram. It makes it clearly easier to understand. So here we are the dagger. We send this, and with the file per meter and given the value, http attacker.trackme/cmd.txt. So let's, the figure above is an example of steps of successful RFI. Let's say the attacker paste a PSP file on their server. So basically, cmd.txt is the command. Inject a command to execute commands, arbitrary commands, and it just could be anything where we could, let's say it's lo.trackme, and let's try to get that on to that on their server stuff. Here we send the request up, and then the SDB get request is being sent from http web app TryHackMe to attacker.trackme/cmd.txt, and the server is basically trying to get the cmd.txt from via the GET request and send the content of cmd.txt from the attacker machine to the web server, and it includes the content of cmd.txt to the include function and executes it. And as a result, send back the result of execution with the get.php page. And as a result, the cmd.txt was triggered, and if cmd.txt could contain something malicious, then we would be able to execute arbitrary commands and thus would be eventually gain an RCE. Yeah, so jumping on to task note 5, so what conventions we can use as a developer is important to be aware of web application vulnerabilities, how to find them, and prevention methods. So what are the prevention methods? Are to keep system and services, including web application framework, updated with the latest version, turn off PSP errors to avoid digging path, a web application firewall, WAF is a good option to help minimize the web application attacks, and it would eventually minimize, but preventions is better, and disable some PSP features. Carefully analyze and allow only protocols and PSP wrappers that I need. Never trust user input. And implement whitelisting for file names and locations as well as blacklisting. So if we don't want to show HC password to normal users, then you could basically whitelist that file and only certain users to have access for that. So now jumping on to challenge. So great job. Now applying the techniques you have learned to capture the flags, familiarize yourself with HTTP web basics could help you complete these challenges. Make sure that ashvm is up and running in text or PHP. So steps for testing the LFI. So 6, playground, I guess. Find an entry point that could be via get, post, cookie, or CTV header values. Enter a valid input to see how the web server behaves. Enter invalid input, including special characters and common file names. I don't aware, so let's try. So we can see if we would just don't supply any inputs. So there are This is the directive where /www/estima/playground.php, which is the current directory, and this include function, and we are currently in vs/w/w/ the CML capture the flag at etc/1. So let's try getting etc/file 1. What do we get? So no such file. So if we could just, what can we use eventually on this? So the first and the basic one LFI, just trying to get back to the 4 directories and trying to get at c/flag1. So let's try getting 4 directories back. 4 directories because we discussed that there are the user is in this playground.php, which is in 3 further directories, and so then we will try to get the output of etc flag 1. Oh, I guess. I'm sorry. Let's try to. So what might be causing the error? // or does /flan or /flagger / c/flag1. Okay, let's try again on this same. So jumping 4 directories pad.3/1./2/3 and /floor, then at c/flag1 ./1./2, jumping into jumping vet2 directories, jumping vet3 directories, jumping vet4 directories, /at c/flag1. Oh, strange. So what can we do over here is just try to if we could capture the request via burp and try to replace get with the post and refresh the page, finally the file in parameter. Where is this? So include a file in the input form below. Let's try changing the parameter from input to go from get to post. So we would need our perp. I'm sorry, it's quite a bit slow, this perp. So if I specify why we are changing from basically get request to post request is basically we need to get this executed to jump back from etc/flag/from, but they want us to use post instead of get. Get is normally used for greet files from the server, and post is generally used for getting the contents, and thus we will use the post request, and generally we would get the flag as a result of this. I accept. Next, Starbird. Okay. Proxy intercept on. Open browser. Oh, sorry, we need to use Fox proxy here, as there isn't available on TryHackMe. So now jumping on to the final task of this LFI room. So great job. Now apply the techniques you have learned to capture the flags. And here we will be demonstrating some real LFI challenges. And here is the lab for this. And we need to find an entry point that could be either where get, post, cookie, or HTTP header values. Enter a value input to see how the web server behaves. And yeah, so for the first challenge, we have to get for etc flag 1. So let's try to get back 4 directories and specify etc flag 1. Okay, we have to change our method from to post request with the file parameter, and I would be using a command line utility called curl, as my dad burp requires some configurations on the attack box, or even calling enet on TryHackMe. So yeah, we would be using command line utility call curl. We will be specifying up. Here we can clearly see we will be specifying file parameter, and we specified with the X flag about changing our method request post, and we will eventually get back to 4 rights active flag in the URL right there. And here you can see we get our flag. So capture flag 2 at XC flag 2, so it might be lab number 2. Refresh the page, please. Welcome guest, only admins can access this page. So what do we want to need? So we are unable to access this, and if we open so what this could be, I mean, what can we trial on this even? So the file in the input form below, there isn't even the file parameter. What can we even specify captured applied to? Challenge to include file content. Oh, what can we try? So, let's try to view the source port or inspect the network traffic. Let's try to reload. As we saw earlier on, there was let's try using the hint. This is the hint. Check your cookies. Let me know if you want any help. Oh. Cookies. Value. Where's the cookie value? So cookie values generally in the index storage. Cache storage. Cookies. Drag me. Well, you guessed. Oh. Quite unique up there. So if we could just try an alpha on this, jumping back 4 degrees. 1, 2, 3, 4. Then specifying we want at C flag 2. And then basically reloading up the page. Oh, no way. 500 preview of Etsy flag. Welcome, Etsy flag 2. They were welcome. Capture flag at Etsy flag 2. So to modify the im, what can we do now? It failed. Why it did fail. So the error message is said the validation is done to open.php files only. However, it can be omitted by adding model as 00 at the end. So let's try to add the null byte at the end. So we did learn earlier on about the null byte in this section. Let's try to add a null byte less 0 and let's try to get, oh, no way, we got our flag. So yeah, now jumping on to challenge 3. So let's try manually. What do we get on the first drive? So it looks like we are in /challenges3.php over here. We have to go back 4 directories. And what can we try? So what can we try on this? And let's try it for the first, even the simple one, the most effective one also. Let's try to manually get Etsy flaggery. Capture, let's try to get the hint. This is the hint you're looking for. Not everything is filtered. The website uses request to accept, HTTP request to research to understand what it accepts. Include a file in the input form, and we are going to so let's try passing the input normally and jumping back pfiled, and it says for the .php to be essential, let's try adding the nil byte we discussed earlier on. Okay. And what does the hint says? Okay, so we were needing to send up the post request now as well. So I would be using the command line utility again. One line utility curl. And what was that? Let's try to use curl, and I did specify it up. So this I did try earlier on. So what we would use is try to post up the request with the curl, and we are specifying with the entire the same request, but generally using the post method, and to avoid any binary errors that the curl gives, just save the output to flackery r2.txt, and let's try to view gathru flackery or flag txt, and yeah, here we got our flag. So now the final, again in RCE in the at playground.psp with rfi to execute a hosting command. What is the output? I want to execute a hosting command. So let's try to solve this real quick as well. Oh, I got 5 nets on my machine. I hope I would do. So what can we apply? First, let's try to get that rin host or txt. Once we are going to save host or txt, that would display up as we discussed.
Host.
Or dx2, a command to generally get to know about that particular host. We are we would be using PHP to get the host name. So if you might not know what this is, basically this would print up the host name, and we are short on time as well, 4 minutes. I hope we will be able to solve. So let's try what my IP is over here as well, as we would be all able to. We want to get to curl as well.
What?
Is my IP is comes up. IF confetti. IP confetti. Oh no. It was IF confetti ain't working. Strange. So it was IF confetti, but IF confetti ain't working on the callie. Fetty. Oh no. My guess that we can try for looking at our IP, your Tinder, and my. Yeah, so this is right piece. Please read, don't mind the method I use, as the if on fake isn't working right now. So we would try to host a Python server on port 80 real quick. Python 3 /m http tert server, and then specify the port 80. I will do 8070. And then we will try to get the hostname.txt and hostname.txt by specifying in the file of, I guess, in the file parameters let's try. Yeah, so here we will use, we are 2 nets, you will get that, 10.10 and IP, and the port number was 87087, and 070, as I remember, 8070 /host name .txt. Fingers crossed. Let's hope for the best. Failed to open 8070.
No way.
8070. We should have the hostname.txt. Alas, CD. Alas, host or txt. Oh, sorry.
We are.
Release the unknown time. Host.txt, fingers crossed. What's happening over here? $8070. The file we are getting /host.txt. We are also getting hostname to print up. Then what might be the problem? /host.txt. Oh, let's try to enter that in this field. Oh, that's quite strange, to be honest. I didn't expect that. Why is it failing up? Oh, specify. Oh, sorry. Oh, I'm really sorry. I didn't specify that. The protocol being used.
Oh no.
I just messed up. I hope I would get that. Splash. To see the file, and then we would specify up the protocol, GDP, then our IP, and then, oh, not bad. So we very close at that time, but eventually, yeah, so that did work up, and eventually the flag was retrieved. Let's submit, and we would complete our file inclusion, and I hope you enjoyed that. Keep learning, keep exploring, and always stay anonymous.